Hi, everybody. Welcome back. This is Professor Reitz, Math 1375 Pre-Calculus, and this is the first of our Spring 2020 COVID-19 distance learning lectures. Welcome. You're going to see that I break this up into relatively short chunks, 10 minutes or less. So this will be an introducing the topic, and we'll do an initial example, and then we'll get into further examples and the method for solving them in later videos. Here we go. Oh, and bear with me. I'm just learning much of this technology, getting used to it, so bear with me as I fumble my way through it. No doubt you will see me improve as I go. I hope so. All right, here goes. Today we're talking about polynomial and rational inequalities. We've been talking about polynomials a lot, and this is just introducing the notion of inequalities. An inequality is just one of those guys, less than or equal, greater than or equal to. And polynomial inequality is just one of these that has a polynomial on each side. So what we're going to do is we'll go ahead and look at an example. So for our first example, let's take a look at this one. So things to notice, first of all, it has that inequality sign, greater than or equal to. The left-hand side is a polynomial, x squared minus 3x minus 4. And the right-hand side is also a polynomial, it's just a very simple one, 0. And basically, the question that we're trying to answer here is, what are the numbers x that we can put in here for x that make this inequality true, that make the left-hand side actually come out to be greater than or equal to 0? And just to get a feeling for it, let's try just doing a couple of tests. So for example, we can test the number x equals 0. When we plug 0 in, to the left side, we get 0 squared minus 3 times 0 minus 4, and that's all equal to negative 4. And that is not greater than or equal to 0. That's less than 0. I'm going to put an x next to say the number x equals 0 is not one of the numbers we want to capture for our solution. The solution, when it says solve one of these, we want a list of all the numbers that make this thing true. Let's try testing something else. So for example, let's test x equal to 5. And here we get 5 squared minus 3 times 5 minus 4. And it gives us 25 minus 15 minus 4, which is equal to positive 6. And that one is indeed bigger than or equal to 0. So that means that 5, we are going to include it when we list our answers. That's definitely one that works. We could keep going. We could try a negative number, x equal to negative 10, let's say. And here we just have to be careful when we plug in negative 10 squared minus 3 times negative 10 minus 4. And this thing is equal to, well, so I think it's equal to 134. In any case, it is definitely bigger than or equal to 0. And because of that, this one works also. And this is also a number that we're going to want to capture. So far, we've tested 3 numbers. X equals 0 didn't work. It's not part of our solution. X equal 5 did work, and x equal negative 10 did work. Okay, so what we want to do, somehow, of course, there's a lot more numbers than that. So we would like some way of kind of reaching an answer without testing every single number. And one way we can do this, you'll notice that the left-hand side of this inequality, here, let's just box this thing so that we can come back to it easily. The left-hand side of this inequality, the x squared minus 3x minus 4, that thing is a polynomial, and that's a polynomial that we can draw the graph of. So let's go ahead and look at the function, which is just the left-hand side, f of x equal x squared minus 3x minus 4. Now, I have a graph of this function here. here's what it looks like. You can see that this function is a parabola, and it has two places where it crosses the x-axis, right here and right here. It looks like that's at x equal -1 and x equal 4. We can confirm that in just a minute, but you'll notice that those places, for example, this one is -1, if we plug that into the function, what we're going to get is all going to equal 0. I can tell that because that's where it crosses the x-axis. So when we put in x is -1, we get a y of 0. Now, since we're looking for places where this x squared minus 3x minus 4, where the result of that is greater than or equal to 0, then I would include that number in our answer. I'm going to color green for numbers that we're going to include in the answer. And similarly for the one up here, this is where it's equal to 0. We would include that in the answer. And then from either one of these, starting at this point here, if we look to the right, when we plug in numbers along here on the x-axis, the corresponding y values down here are going to come out negative. So when we plug in x equals 0, we get -4. That was one of the test cases that we did. And so that means that we're not going to include this x number in our answer. And visually, you can see that this is going to be the case because the function is less than the x-axis. The x-axis is like 0. And all to here comes out less than 0. And that means that the places that we're going to want to include, along with the two places that equal 0, are the places where it's above the x-axis. That's on the left-hand side and on the right-hand side. We'll just color those in. So we want to capture these parts of the function. But of course, this parts of the function, the way that I've drawn them, they have both x's and y's in them. And what is sort of our challenge is that we just want to look at this and just extract out what are the x's that work here. So for all of the parts that are in green here, I want to look at just focusing on the x-axis itself. What parts of the x-axis give us the parts of the function that are above the x-axis? And it's any x starting here at x equal -1 and going any way to the left is going to give us things above the x-axis, and that is the interval -∞ up to -1. Now, I'm including -1 because when we plug -1 into this function, it gives us 0. Similarly, on the right-hand side, starting at 4 and moving to the right, anywhere in there is part of our solution. It gives us, if we plug in one of those x's, then we get a y value that's positive, that's above the x-axis. And so this goes from 4 up to infinity. And it's these two intervals together that give us our answers. So let's just make it official. Our answer to this thing is -∞ -1 union 4, infinity. So, first of all, this is complete, and second of all, you should be left with some questions. Notably, first of all, how the heck do we do this if we don't have the graph to look at? And then second of all, I kind of just picked these numbers, the -1 and the 4, just from the graph. How do we get those numbers and make sure that they're really exact? So that's kind of what we're going to be looking at next. How do we attack this thing if we don't have the graph to look at, or how do we verify that what the graph suggests is really precisely accurate?